So if someone was to ask you what the effect of exercise is on the body, I'm sure you've got a valid answer, but is it what AQA want to hear? And what they want to hear is an answer that links to the respiration equation. Hopefully by the end of this video, you will be suitably trained in producing those model answers. So effectively, when you exercise, your muscles contract at a greater rate. So there is an increase in muscle contraction. In order for muscles to contract, they need energy, and that energy comes from respiration. So there is an increase in respiration. For respiration to work and release that energy, you really want that respiration to be aerobic because you get 32 joules of energy with aerobic respiration, which is far superior to anaerobic respiration. But for respiration to work aerobically, you need oxygen. So there is an increased demand for that oxygen, and to supply that oxygen to those cells, you've got to take in more oxygen from the environment. So your breathing rate will increase. And that not only gets the extra oxygen in, but if your muscles are respiring at a greater rate, they're also going to be producing a lot more carbon dioxide. And carbon dioxide will build up in your bloodstream and form carbonic acid, which isn't a good thing. Enzymes wouldn't really like your blood to be too acidic. So you need to get rid of that excess carbon dioxide, and you do so by breathing out. So your breathing rate increases for those two reasons: get the extra oxygen in and get rid of that extra CO2. However, there's no point in simply oxygenating the blood because you need to get that blood around the body. And the heart does that job, but the heart needs to do that at a faster rate. So the heart rate increases, or your pulse will increase. This helps to push more of that extra oxygenated blood that also contains the glucose necessary to fuel that respiration reaction in those muscle cells. The other reactant in respiration is glucose. When this runs out in the bloodstream, there is a backup supply, and it's in a stored form of glucose called glycogen. And regular exercise will help to build up more of these glycogen reserves, so you've got more glucose to sustain that extra muscle contraction. So there are other side effects of doing exercise, and that is you're going to get really hot. Your body temperature is going to increase, and that's because respiration is an exothermic reaction. It releases heat energy, and that's going to raise your body temperature. But not only do you get hot, you need to cool down. So there are coping mechanisms that your body will display, such as increased sweating, and blood vessels near the skin will widen to allow blood to flow closer to the skin, and if you're quite pale in complexion, you will noticeably appear redder as a result. Now there's lots of arrows here pointing upwards. That's my abbreviation for the word increase, and you need to use this. It's very easy for students to slip into a habit of saying that during exercise, cells need oxygen and they need glucose, but they always need this. So you need to specify that when you're exercising, you just need more than the normal amount. So more or an increase is fine, and you will have to use those words in your answer regularly to get the marks in the exam. It's quite often in this topic that you will be presented with some data in the form of a graph that you will need to analyse. Here are two very similar graphs that you might need to compare or be able to explain using your own biological knowledge. So we've got time along the x-axis here, and along the y-axis you have got beats and breaths per minute. So the beats per minute is the heart rate, and the breaths per minute is associated with the breathing rate, and they're colour-coded as you can see here. So initially what we've got is a breathing rate and a heart rate that is on a level platform, and we would say that this is the resting breathing rate or the resting heart rate, which you can easily measure by measuring your pulse for a minute, and that will be your resting heart rate, or record the number of breaths you take in and out per minute, and that will be your resting breathing rate. Here on the graph is where the exercise will begin, and as you can see that there is an immediate increase in both the heart rate and the breathing rate to a maximum point, and after this point the two graphs start to look very different. In this first graph you will see that both the heart rate and the breathing rate fall, and they start to return to the resting breathing rate and the resting heart rate. The period of time between the end of the exercise and the return to those resting levels is called the recovery period. In contrast with this second graph, when the exercise finishes, the heart rate kind of stays quite high, and so does the breathing rate. And this graph might be modelled on somebody who is carrying out exercise that is anaerobic, in which case they have built up a certain amount of lactic acid in their bloodstream, and lactic acid is toxic and it needs to be broken down by oxygen. So following a period of intense activity or anaerobic exercise, a person has what's called oxygen debt, And this basically means that after the exercise has finished, they will need to actually breathe in a lot more oxygen and pump that oxygen around very, very quickly to break down this lactic acid into carbon dioxide and water. Only after all the lactic acid has been broken down will the heart rate and breathing rate fall back to their resting levels. In this second graph, the recovery period is a little bit longer. And if you're comparing recovery periods between two sets of data, if they're based on two different individuals, one might say that the first graph is based on an individual that carries out regular exercise and therefore is fitter, and the second graph is based on somebody who probably doesn't exercise and is quite unfit. And this indicates that by doing exercise on a regular basis, you will build up your levels of fitness. Your recovery times will be much shorter. One of the reasons for this is that when you do exercise, you're building up extra muscle, and those muscle cells are packed full of mitochondria that carry out aerobic respiration. If you have more of those, you're going to be able to effectively fuel yourself for much longer. And those muscle cells will also store surplus glucose in the form of glycogen. Equally, regular exercise will help to improve your heart as a muscle itself, as well as lung function. So moral of the story is, get out there and do some exercise. It's good for you.